Hello, my name is Chloe Dowell, and this is my Physics 105 final project. My example Rube Goldberg machine can be found here at this YouTube link. It's a very simple machine with a few inclined planes, levers, and a pulley system. My example of kinematics in this video is in the form of a marble rolling down an inclined plane. This allows us to assume that we could find the velocity and displacement with the two equations shown below. Here in this example, we can see the marble rolling down an inclined plane into a pulley system. If we're wanting to find the final velocity, we will also need to know the initial velocity, the acceleration of the marble, and the time it takes the marble to roll down the plane. If we're wanting to find the final position or displacement, we will also need the initial position, and that's going to be the distance between these 2 points here. We will also need the rest of the variables to determine the displacement. My example of forces in this video is shown by a second marble rolling down another inclined plane into an angled pipe. This shows the forces of gravity on the marble. The equation to find force of gravity is known to be the mass of an object times g, or the acceleration of gravity. Here we can see the mass of our marble, and this is going to be the downward acceleration due to gravity, and we'll multiply these to find the force of gravity. My work and energy examples in this video are the potential energy of gravity, which we find by multiplying the mass times the acceleration of gravity times the height. My second example is kinetic energy of the car rolling down the second inclined plane. We find this with the equation k equals 1/2 times mass times velocity squared. We're going to see our potential energy here at the top of the first inclined plane. We find this by knowing the mass of the marble, the downward force of gravity, and the height. If we're wanting to find kinetic energy, we'll need the mass of the car, the mass of the marble, the velocity of the car, and the velocity of the marble. My momentum example in this video is when the first marble comes out of the angled tube and hits the first car, transferring its momentum. We know that the equation for momentum is as follows: P equals mass times velocity. We're also aware that initial momentum must equal the final momentum. Therefore, P initial will also equal P final. Here is the velocity of the car, and here is our mass of the car. We will also need to find the mass of the marble and the velocity of the marble. To find our initial momentum, we'll use the mass and velocity of the marble, and to find our final momentum, we'll use the mass and velocity of the car. My example of torque in this video is when the first car hits the first lever and pushes the second car into motion. We'll find this by using the equation torque equals force times distance times the cosine of an angle. In this example, the force exerted on the lever is kinetic energy from the toy car. Here we can see the two forces of the cars, the car pushing on the lever and the lever pushing on the second car to put it into motion. This is also going to be the distance of the lever, therefore we can find torque. Thanks for watching and hope you have a great summer.